Hi dear students, welcome back to physics class. Problem number 14. Find the first one, maximum frequency, and second one, minimum wavelength, of X-rays produced by 30 kV electrons produced by 30 kV electrons. Okay, this one is the given question. Find the maximum frequency and minimum wavelength produced by 30 kV electrons. 30 kV, nothing but here 30 kilovolt. Solution given. V is equal to how much here? 30 kV. 30 kilo value 10 to the power of 3 volt. V is equal to 3 into 10 to the power of 4 volt. Okay, this one is the potential difference voltage. Then next one, H is equal to how much here? 6.625 into 10 to the power of minus 34 joule second. Next, first I have to find out the maximum frequency. Okay, maximum frequency means we have to know that energy value. We know that energy or kinetic energy is equal to E V naught or V. Okay, V and V naught, that two are same. E is equal to E value 1.6 into 10 to the power of minus 19. V naught value or V value, potential value 3 into 10 to the power of 4. We have to calculate first one, nu is equal to question mark. Using formula E is equal to H into nu is equal to E divided by H. Nu is equal to E value 1.6 into 10 to the power of minus 19 into 3 into 10 to the power of 4 divided by H value 6.625 into 10 to the power of minus 34. Then nu is equal to 7.24 into 10 to the power of 18 hertz. This one you call as frequency. Okay, maximum frequency. Then second one, lambda is equal to question mark. It is the minimum wavelength. We know that the formula, we know that C is equal to nu lambda. Lambda is equal to C divided by nu. Okay, lambda is equal to C value 3 into 10 to the power of 8 divided by nu value 7.24 into 10 to the power of 18. 7.24 into 10 to the power of 18. After simplifying, we get the answer 0.414 into 10 to the power of minus 10 meter. Okay, this one is the final answer. Problem number 14 over. The next problem number 15. Problem number 15. What is the de Broglie wavelength? What is the de Broglie wavelength? What is the de Broglie wavelength? De Broglie wavelength associated with a, first one, an electron moving with a speed of 5.4 into 10 to the power of 6 meter per second. This one is the speed. And the second one, a ball of mass 150 gram traveling at 30 meter per second. 30 meter per second. This one is the given question. Solution: A, for the electron, m is equal to 9.11 into 10 to the power of minus 31 kg, mass of electron, and velocity 5.4 into 10 to the power of 6 meter per second. De Broglie wavelength formula, we know that formula, lambda is equal to h divided by p. Lambda is equal to h divided by p means here m into v. Okay, lambda is equal to h value 6.625 or 63 into 10 to the power of minus 34 divided by m value 9.11 into 10 to the power of minus 31 into 5.4 into 10 to the power of 6. Lambda is equal to, after simplifying this one, we get 0.135 into 10 to the power of minus 9 meter, or lambda is equal to 0.135 nanometer. Okay, this one is the wavelength. Then after that, B, mass m is equal to how much? 150 gram. It means 0.150 kg. Gram converts to kg. And velocity 30 meter per second. De Broglie wavelength, lambda is equal to h divided by m into v. H value 6.63 into 10 to the power of minus 34 divided by m value 0.15 into 30. Then lambda is equal to 1.47 into 10 to the power of minus 34 meter. Okay, this one is the wavelength. Okay, dear students, we saw, okay, we have to calculate it, both first one and second one. Okay, we have solved first one wavelength and second one wavelength. Okay, once again repeat this one. Given data for an electron, m is equal to mass of an electron, ಎಷ್ಟಿದೆ 9.11 into 10 to the power of minus 31 kg ಇದೆ. ವೆಲಾಸಿಟಿ ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ 5.4 into 10 to the power of 6 meter per second ಇದೆ. ವೇವ್ಲೆಂತ್ ಫಾರ್ಮುಲಾ ಏನು ಯೂಸ್ ಮಾಡ್ತೀರಿ? ಡಿ ಬ್ರೋಗ್ಲಿ ವೇವ್ಲೆಂತ್ ಲ್ಯಾಂಬ್ಡಾ ಇಸ್ ಈಕ್ವಲ್ ಟು h divided by p ಅಂದ್ರೆ p ಅಂದ್ರೆ ಮೊಮೆಂಟಮ್ ಇದೆ, ಲ್ಯಾಂಬ್ಡಾ ಇಸ್ ಈಕ್ವಲ್ ಟು h divided by in the place of p m into v. Lambda is equal to h value, m value, v value. Its answer 0.135 nanometer. Second in question ಏನಿದೆ? A ball of mass 150 gram traveling with the speed of 30 meter per second ಇದೆ. ಇದಕ್ಕೆ ಡಿ ಬ್ರೋಗ್ಲಿ ವೇವ್ಲೆಂತ್ ಏನಾಗುತ್ತೆ? ಮಾಸ್ 0.150 kg ಅಂದರೆ ಗ್ರಾಮ್ ಕನ್ವರ್ಟ್ ಕೆ ಜಿ ಮಾಡಿದ್ದೀವಿ. ವೆಲಾಸಿಟಿ 30 ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್ ಇದೆ. ಅಂದರೆ ಬೋತ್ ವಿ ಆರ್ ಕನ್ವರ್ಟೆಡ್ ಟು ದ ಫಾರ್ಮ್ ಆಫ್ MKS ಯೂನಿಟ್ಸ್. ಲ್ಯಾಂಬ್ಡಾ ಇಸ್ ಈಕ್ವಲ್ ಟು h divided by mv, h value 6.63 into 10 to the power of minus 34 divided by m value 0.15 and v value 30. Then lambda is equal to 1.47 into 10 to the power of minus 34 meter. Problem number 15 also over. Next, problem number 16. What is the de Broglie wavelength associated with an electron accelerated through potential difference of 100 volt? ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ ಇಲ್ಲಿ? ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊಲ್ಯೂಷನ್, ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ V is equal to 100 volt. de Broglie wavelength formula 1.227 divided by root of V nanometer. ಇಲ್ಲಿ ಏನು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು ಅಂತ ಹೇಳಿದರೆ de Broglie wavelength. You have to calculate de Broglie wavelength, that is lambda is equal to question mark. Apply the formula. Lambda is equal to 1.227 divided by root of V means here 100 nanometer. Root of 100 means here 10. Lambda is equal to 1.227 divided by 10 nanometer. Then lambda is equal to its answer 0.123 nanometer. This one is the de Broglie wavelength. Okay, it's a simple problem. And a problem number 17. Problem number 17. Calculate the momentum. Calculate the first one, momentum, and second one, de Broglie wavelength. De Broglie wavelength of the electrons. De Broglie wavelength of the electrons. Calculate the first one, momentum, and de Broglie, second one, de Broglie wavelength of the electrons also accelerated through a potential difference of 56 volt. ಇದು ಕ್ವಶನ್ ಇದೆ. ಏನು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು? ಒಂದು ಮೊಮೆಂಟಮ್, ಇನ್ನೊಂದು de Broglie wavelength. ಗಿವನ್ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ? ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ? 56 ವೋಲ್ಟ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಓಕೆ, ನಾವು ಗಿವನ್ ಡಾಟಾ ಬರೀರಿ. ಸೊಲ್ಯೂಷನ್, ಗಿವನ್ V is equal to 56 ವೋಲ್ಟ್. H ಎಷ್ಟಿದೆ? 6.63 into 10 to the power of minus 34 joule second. Mass of an electron ಎಷ್ಟಿದೆ? M is equal to 9.1 into 10 to the power of minus 31 kg. ಇವೆಲ್ಲ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ವ್ಯಾಲ್ಯೂಸ್. ಎಲೆಕ್ಟ್ರಾನ್ ಚಾರ್ಜು 1.6 into 10 to the power of minus 19. ಓಕೆ, 19 ಕೂಲಮ್. ಏನು ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಬೇಕಿಲ್ಲ ನಾವು? ಫಸ್ಟ್ ಒನ್ have to calculate momentum. First one, P is equal to question mark. Second one, B, lambda is equal to question mark. ಎರಡು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕಾಗಿದೆ. Okay, in this problem, first when we are apply de Broglie wavelength, lambda is equal to 1.227 divided by root of V. Root of V means it is a which one? Potential difference. After getting wavelength, find out momentum. What is the momentum formula? Lambda is equal to h divided by p. Then p is equal to h divided by lambda. It means first we have to calculate de Broglie wavelength. ಈಗ ನೀವು de Broglie wavelength find out ಮಾಡ್ರಿ. de Broglie wavelength ಫಾರ್ಮುಲಾ ಏನಿದೆ ಇಲ್ಲಿ? 1.227 divided by root of v nanometer ಅಂತಿದೆಲ್ಲ. 1.227 divided by root of 56 nanometer. ಇದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದಾಗ ನಿಮಗೆ ಬರೋ ಆನ್ಸರು 0.1639 ನ್ಯಾನೋಮೀಟರ್. ಇದು ನಿಮ್ಮದು ಆನ್ಸರ್. ಓಕೆ, we got de Broglie wavelength. After calculating this one, find out second one, that is the this ಯಾವುದು find out ಮಾಡ್ತೀರಿ ಈಗ p is equal to h divided by lambda. This one is the momentum. ಇದು ರಿವರ್ಸ್ ಮಾಡ್ರಿ, ಇದೇನಂತ ಅಂತ್ರಿ, this one is considered as an A and this one is the B. P is equal to h value 6.63 into 10 to the power of minus 34 divided by lambda value 0.1639 into 10 to the power of minus 9, ಯಾಕಂದ್ರೆ ನ್ಯಾನೋ ಅಂತಿದೆ. Then P is equal to ಎಷ್ಟಾಗುತ್ತೆ ಆನ್ಸರ್ 4.04 into 10 to the power of minus 24 kg meter per second. This one is the final answer, momentum. ಏನು ಫೈಂಡ್ ಔಟ್ ಮಾಡಿದ್ರಿ ನೀವು? momentum ಫೈಂಡ್ ಔಟ್ ಮಾಡಿದ್ರಿ. Problem number 17 also over. Okay, problem number 18. This one is the last problem in this chapter. An electron and a photon each have wavelength of 1 nanometer. Find momentum energy and kinetic energy. Solution: given h is equal to constant value 6.63 into 10 to the power of minus 34, wavelength lambda is equal to 1 into 10 to the power of minus 9 meter, and mass of electron me is equal to 9 into 10 to the power of minus 31 kg. Okay, this one is the given data. First you have to calculate momentum. P is equal to question mark. What is the formula for P? Momentum. P is equal to h divided by lambda, because lambda is equal to h divided by P. It is the de Broglie wavelength. Then substitute the value. P is equal to h value 6.63 into 10 to the power of minus 34 divided by lambda value 1 into 10 to the power of minus 9. Its answer 6.63 into 10 to the power of minus 25 kg meter per second. P is equal to 6.63 into 10 to the power of minus 25 kg meter per second. This one is the momentum. First one over. Then energy E is equal to h nu. E is equal to h nu means C divided by lambda. E is equal to h value 6.63 into 10 to the power of minus 34. C value 3 into 10 to the power of 8 divided by lambda value 1 into 10 to the power of minus 9. Okay, this one is the value. In terms of energy, it is of joule is there. It converts to electron volt means, in terms of electron volt means, divided by 1.6 into, this one is divided by 1.6 into 10 to the power of minus 19. Its answer E, answer 124.3 electron volt. Energy we are convert in terms of electron volt, joule in terms of electron volt. Then third one, kinetic energy is equal to question mark. Kinetic energy formula half into m into v square, 1 divided by 2 m into v whole square divided by m. Here we are multiplied by m. Then 1 divided by 2 m into v means p square divided by m, because p is equal to m into v. Then kinetic energy is equal to 1 divided by 2 into p square value. What is the value of p here? 6.63 into 10 to the power of minus 25 whole square divided by m. Mass of an electron 9 into 10 to the power of minus 31. Okay, this one is in terms of joule is there. Convert in terms of electron volt means half into 6.63 into 10 to the power of minus 25 whole square divided by 9 into 10 to the power of minus 31 into 1.6 into 10 to the power of minus 19. Kinetic energy is equal to answer 1.52 electron volt. 1.52 electron volt. Okay, up to here I completed the numerical problems on dual nature of radiation matter. In tomorrow class we start the next new chapter, that is atoms. Thank you.